For those who don't know what peer review is, basically you write a paper, you send it off to a journal, or increasingly, and this will be part of the resolution of the rant I hope, increasingly you just submit it to a server where it's available online even before peer review. But traditionally, take the paper, send it off to a journal. The journal's editors, first of all, consider, is that paper worthy for this journal? If it is, they send it out for peer review.
Who do they send it to?
They send it to your peers. Now the difficulty is, so your peers mean people in the field, hopefully experts in your field, hopefully people who you would think could do a very good job at looking through your paper, criticising it, critiquing it, coming back with generally, I must admit in my case, generally constructive criticism. There are very few cases I can point to where a paper, in our case, hasn't been improved by peer review. And of course you get angry and you go, oh, what did this reviewer knows nothing. But actually, when in the cold light of day, which is difficult for me, and one of the reasons I don't have a Twitter account, in the cold light of day, when you stand back, you realise actually they may have a point here, so let's think about doing this. So peer review, in that sense, that's the good things about peer review. So this entire process is anonymous. The traditional peer review process is anonymous. So often, yes, there is the very strong possibility that when your paper goes out, that it goes to somebody you know. And most times people keep that information confidential, but certainly sometimes I've had people come up to me and go, well, I reviewed your paper some time ago. That's an interesting sociological quandary to be in, because obviously if you get a favourable review from somebody and they've told you they're giving you a favourable review, you're almost biased if you get their paper to review. So there's there are issues there. The vast majority of the time, I must say those are rare occasions, the vast majority of the time is you do the review and it's entirely anonymous.
I know science is very collaborative, but there is an element of competition in it for some people. Do you ever worry that someone's going to try and nobble your paper?
That's very many people worry about that. I'm less concerned about that, I must admit. I've certainly not really had any experience of that in the sort of 120, 130 odd papers. But the journal guidelines, which they send to referees, specifically mention this. And there are strong ethical guidelines. Whether those are always followed, I don't know. And certainly there are some, scientists are human. And some are more human than others. That's the good aspects of peer review. It should work to sift out problems with the interpretation, problems with the results. It should work to improve a paper. The problem is the number of papers goes up and up and up, the number of scientists goes up, and the number of journals goes up and up. There's a huge volume of stuff and we are increasingly getting swamped. Now, I came across this relatively recently, but it's from the middle of last year. This is one of the worst examples of where peer review has entirely failed. So, what are we looking at? We're looking at a transmission electron microscope image of gold nanorods. So you see these rods, which are about, you can see from the scale bar here, 50 or 60 nanometers long. And they've basically been synthesized in solution and they've been put onto a surface. And you get these structures forming. And the authors, because of course if you want to get a paper into a high-profile journal, you need to have a snappy title, so they termed this, or coined the term, nano chopsticks. There's too much nano out there, so nano chopsticks in this case refers to, well, you can see that there's a very well-defined angle. And for me, sort of when I look at that image, I go, wow, that's mad. That's really strange. Why would they do that? Why, when you deposit them from solution and all the different types of dynamics that goes onto solution and the drying of the solvent, why the hell would they do that? Why would you get these very well-defined angles? And then you zoom in. Well, we zoom in after the event. This was caught by this wonderful blog Chembarg, but was missed by the reviewers. All right, do you see anything suspicious there, Brady?
I mean, I'm not brilliant at Photoshop.
And neither am I, but for Zarquan's sake, that is just taking the excretory fluid, isn't it? It's beyond a joke. How the hell did that get through peer review? If you get an image like this top one, and you see that, the first thing you do is...
Hang on.
Sorry.
That's terrible.
It is. We laugh about it, but this is hundreds of thousands of pounds of taxpayers' money in many cases going to fund this type of research. And this damages confidence right across the board in science. This is not some very poor quality journal at the bottom. This is one of the top the top ranking journals in the field. And you can make the argument, well, the referees can't be expected to catch everything. And if you're one of those referees, I'm sorry, and I appreciate that you've got large workloads. We all have large workloads, but you sent a paper which is related to how rods interact and form these structures. The first thing you as a referee, or the first thing I think anybody in this field would do, would go, well, that's really interesting. What the hell's happening at the apex? And then you'd go looking for high resolution images, and then you'd find this in the supplementary information. They overlap. They cut it out. The background doesn't look the same. You can see this little notch here is a feature that's repeated because they've used the same image and just rotated. My 10-year-old daughter said, Daddy, why didn't they cut it out correctly? And here's the really troublesome aspect. Here's the really...
Oh, they're onto you.
I didn't mean it. I take it all back. This is the lawyers. Hello?